All right, partitioning a line segment. Think about the word, what partitioning means. Partition, to cut into parts. All right, so when they talk about partitioning a line segment, we're going to have a line segment, we're going to be cutting it into different parts. That's going to be a big part of this lesson. First of all, what is a directed line segment? You're going to see that phrase, directed line segment. Well, we should all know what a line segment is. A line segment is, basically just a segment of a line, right? So we have endpoints. And the only difference with a directed line segment is it has direction. It has distance, obviously, it has length or distance, but it also has direction. So if I say directed line segment AB, okay, directed line segment AB, that would be this, going from A to B, going from A to B. If I say directed line segment BA, that means going from B to A. Starting with, and the reason that's going to be important is because, like right here, for example, we're going to partition line segments in a ratio. If they say ratio AB 1:3, that means I got to break it into 4 parts. Why 4 parts? Because I need 1:3. 1, and see 1 here, and then 3 here. And that's what this lesson is going to be about. Then we're going to do it on a graph. It's actually pretty simple. All right. Let's see here. So, like I just said, a ratio of 3:1 would be 4 parts. So you could either go from, if it's a ratio 1:3, that's from A to B. There's 1 here, and then there's 3 parts here, and they got to be equal parts. If I did 3:1, there's 3 parts from A to the point, and then there's 1 part right there. But notice how a ratio of 1:3 or 3:1, it has to be 4 parts because you got to have 3 and 1. You add them together basically. Okay. Down here, if it's a ratio of 2:1 or 1:2, same thing. 1:2, there's going to be 3 total parts. So here's the 1. Oh, my mouse is going a little crazy right now. Here's the 1 and here's the 2. So here's 1 and then here's 2. 1 and 2. This one is 1 and 2. All right, and that's a 2:1 ratio, but that's going from B to A. See how it's going B to A? We're gonna practice where it starts in these examples here. Okay, so that's kind of what we're getting into. That's an overview of what we're getting into. I just want to go down a little bit here and knock us up. All right. So determine the ratio of the directed line segment BA. So see how it says BA? That means B going to A. Start at B. All right, write that down. Start at B. Very important that you start at B. So we got to find the ratio. So starting at B, look, first of all, how many pieces are there? 1, 2, 3, 4, 5. There's 5 pieces. So my ratio has to add up to 5. It's either 3:2 or 1:4, something like that, right? Well, here's point P. There's point P right there. There are 2 pieces here, and there are 3 pieces here. So my ratio is either 2:3 or 3:2. But it's important that you write it the correct way. Because we're starting at B, the 2 comes first. All right, it's 2 pieces here and then 3 pieces. So this is a 2:3 ratio. Let's do another one. Again, starting at B. Well, this one, they're equal. There's only 2 parts, right? It's 1, 1. That's pretty easy. 1, 1. And again, 2 pieces or parts. This one here, there's 1, 2, 3, 4, 5. There's 6 parts. 6 equal parts. So the ratio's got to add up to 6. Here's point P. Here's point B. Here's point A. B, P, and we got to start at B. So starting at B, there's 1 segment. And then if I go from P to A, there's 1, 2, 3, 4, 5. There's 5. So it's a 1:5 ratio, not 5:1. See, there's 5 on the left and 1 on the right. That's not how it works. It doesn't always go left to right. It goes by the first letter. The first letter listed is B, so you got to start at B. That's very, very important when you do these. All right, some examples on a graph. Partitioning a line segment means to divide it up into pieces according to a given ratio. All right, basically just a refresher there. All right, for example 2, we are going to use the coordinate plane now. They ask us to determine the point P that partitions the directed line segment AB into a ratio of 2 to 3, and they give you the given point. So we can obviously plot these points. Oh, before we do this one, there's a mistake. This is supposed to be -6. A is supposed to be -1, -6. So we're changing A to -1, -6. That's just a mistake, a typo. All right, so -1, -6. 1, 2, 3, 4, 5, 6. And then 9, -1. So what we need to do, and I'm going to try to connect this the best I can here. What we need to do here is divide this up into how many equal pieces. That's what we're going to figure out first. 2 plus 3. Ooh, a little bit of a delay there. What's going on? 2 plus 3 equals 5. So there's 5 parts, just like we did in the last activity, right? Because it's a 2 to 3 ratio. Now, the directed line segment AB, A is the first letter, AB, so start at A. And then what we're going to do is use the slope. 1, 2, 3, 4, 5, and then over 10. It goes up 5 and over 10. Now the reason I'm doing that is because I know if I need 5 parts and I go up 5, each one is going to be up 1. You get it? Each part's going to be up 1. So I'm going to divide that by 5 and divide that by 5. Okay? If I divide by how many parts I need, that's going to be 1 over 2. So I know I'm going up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2. And there it is. I divided it into 5 equal parts. Now, I need a ratio of 2 to 3. I know this seems easy, but you've got to be careful. I need a ratio of 2 to 3. Okay? Starting at A. That means from A, it's 2 parts. So I'm going to write that down. From A, 2 parts. All right, so I'm going to go. So here's A. I never labeled. I should have labeled. This is B. All right, so from A, I need 2 parts. Boom, boom. There's my 2 parts. There's my point P, because there I have 3 parts here. So this is 2 parts and 3 parts. Point P must be right there. So that's the point 1, 2, 3, down 4, right? So 3, -4 is my point P that partitions the directed line segment into a ratio of 2 to 3. See, right now it's a ratio of 2. There's 2 pieces here and 3 pieces here. All right, let's do a couple more and then we'll be done. Same question, same A to B. Now it's a ratio of 1 to 3. So 1 plus 3, I'm going to switch to a different color. We'll switch to blue. So 1 plus 3 means I need 4 parts. Let's plot. So -2, -5, and 6, -1. I need 4 parts. My, let's see, AB. So start at A, okay, and A is -2, 5, and this is B, okay. My slope, 1, 2, I go up 1, 2, 3, 4, and over 8. My slope is up 4 over 8, but I need 4 parts. So I divide by 4, divide by 4. That gives me 1 over 2. That means I'm going to go up 1 and over 2 for each part. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Almost the same as the one before, right? Except now it's 4 parts. I need a ratio of 1 to 3. So I need, starting at A, 1 is right there. So there's my point P right there. 0, negative 4. 0, negative 4 is my answer. Point P is 0, negative 4. There's my 1, but there's my 1 right there, and there's my 3 right there. This is my ratio of 1 to 3. All right, last example. Same question. Now it's a 3 to 2 ratio. A is negative 2, 4. And B is 8, 9. 8, 9. 8, 9 is B. All right, I need a 3 to 2 ratio. 3 plus 2 is 5 parts. All right, AB. So start at A. And my slope is up 1, 2, 3, 4, 5 over 10. So I'm up 5 over 10. So I want to divide by 5. There's 5 parts. It's going to be 1 over 2 again. All our examples come out to be 1 over 2. So it's up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Sure enough, I have 5 parts. Okay, but where's point P? I need a ratio of 3 to 2 starting at A. So 1, 2, 3. I need 3, and then, oops, yeah, this is not there. There we go. Okay, so there's 3, and then there's going to be 2 there. So there's my point P right there. There's 3 pieces here, and there's 2 pieces here. 3 to 2 ratio starting at A. So point P is at 4, 7. Point P is at 4, 7, and that is it. So pretty simple lesson, and we will practice this in class tomorrow. See you then.